Okay, vector cross product is not too difficult. It's actually fairly simple. The biggest problem is that there's a lot that you need to keep straight, a lot you need to keep organized. So because of that, it's important to write it up in the proper notation. If you don't get the right notation, it's going to be almost impossible to get the answer out on it. Okay, now with the dot product, also known as the scalar product, what you end up with if you have two vectors, let's say vector A and vector B, the dot product basically tells you how much of a projection or how much A would overlap on B. Now when we're talking about cross product, we get something entirely different. In the cross product is going to tell you what is mutually perpendicular to both of those axes. All right. Now we'll get into that a little bit more as we move on here. But basics of the basics, this is going to be much more useful when we talk about electrodynamics later this year. When we talk about work, power, all that lovely stuff, cross product is going to be much more useful. Okay, now let me just modify this here, and then we'll get rolling. Okay, now cross product. Let's say we have two vectors. We have vector A, which is AX I hat plus AY J hat plus AZ K hat. All right, and we want to cross that with vector B, which is going to be BX I hat plus BY J hat plus BZ K hat. Okay? Now, if we want to cross these two, it's a basic mathematical property that we have to go through, but the best way of doing this is to draw it up as a matrix. So, A cross B, this is the general notation for it. A cross B equals, draw it as a solid vertical line here. What we're going to do is we're just going to organize everything into categories based upon what direction we're talking about. So across the top, we're going to use the notation for the general vector directions. I hat for the x direction, j hat for the y, k hat for the z. All right. Then, whichever vector came first is going to be your next row in your matrix. Oh, that was stupid. AX, AY, AZ, and the last one is going to go on the bottom of your matrix. BX, BY, BZ. Okay? Now, in essence, what we're doing here is we're determining how much is going in each individual direction. Now, this is the general format for it. Equals. The best way to do this, and I'm going to have to get a little bit creative. I've never tried doing this before. Normally I can just put my hand in the way and it'll work, but I don't have that feature right now. When we're looking at what is in the I hat direction, okay? When we're looking at the I hat direction, we're going to block out what was under the I hat. We're going to cover that up, and we're only going to worry about the stuff that is over here. Cross product means that we are going here to here, here to here. So, in the I hat direction, it's going to be AY times BZ minus BY AZ. All right. So AY BZ minus BY AZ. All right. So now that we have that, let me see if I can, I don't know if I can even select this to delete it, but we'll find out. Oh, here, I'll do it like this. Once we're done there, we're covering up the column that involves the J hat. Okay? Everything's going to be a plus in between here. Or, I'm sorry, it's plus, minus, plus. So for the next one here, it's cross. So AX BZ minus bx az. I'm going to draw this underneath just because I'm running out of room to the right, but standard notation would be going straight across here. So it's minus ax bz minus bx az j hat plus, I'm going to take this, we're going to drag it over, and we're going to eliminate the z direction. So now it's ax by minus bx ay. In the k-hat direction. Okay? Now, this is the general format for it. This is pretty much how it's going to work. The neat thing about this is when you do this, you're going to always get through what's called the right-hand rule. We talked about it a little bit before. You're always going to get something that is mutually perpendicular to both vector A and vector B. Now, to show you this, to give you a practical example of it, let's just take unit vectors in the, let's do x and y. We have vectors x and y. Vector x is 1 I hat. Vector y is 1 j hat. Now, if we wanted something that was mutually perpendicular to both of these, what we should end up with is a vector that would be 1 in the k hat direction. So if we do it right, that's what we're going to end up with. So I'm going to start with my matrix. X cross y equals I hat, j hat, k hat. Now, x is 1 in the I hat, 0 in the j hat, 0 in the k hat. Y, 0 in the I hat, 1 in the j hat, 0 in the k hat. Okay? Now, I should end up with a vector that is only 1 k hat. In other words, I'm proving that the z direction is mutually perpendicular to the x and the y. Okay? So, let's get my little box up here. I'm going to put, the easiest way to do this is if you put your hand over the x hat, or I'm sorry, over the I hat direction. If you block that out, that way you don't have to worry about what those numbers are. That means that you're eliminating those from the calculation. We're only worried about the other two directions. So it's going to be AY BZ, which is 0 times 0 minus 1 times 0 in the I hat. 0 times 0 is 0, 1 times 0 is 0, 0 minus 0 is 0, which in essence means that I've got 0 I hat here. Okay? Minus. Let's move our box over here. I would just use my thumb if I were you, put my thumb over these two numbers. Come on, now work with me here. Put your thumb over those two numbers just to hide them for the temporary. It's going to be 1 times 0 minus 0 times 0 in the j hat plus, move this over by 1, one times 1 minus 0 times 0 in the k hat. So I'm going to simplify this out like I started to do earlier. 0 times 0 is 0. 1 times 0 is 0. 0 minus 0 is 0 I hat. 1 times 0 is 0. 0 times 0 is 0. minus 0 j hat. I don't know why I drew a k there. I guess I just like redoing these things later. Plus 1 times 1 is 1, minus 0 times 0 is 0. 1 minus 0 is 1 k hat. So my new vector of x cross y is going to be 0i, 0j, 1k, which is what I predicted. If I cross the x direction with the y, I should end up with the z. And that's what I get here. Now, difficulty-wise, this is not too strenuous. The biggest common mistakes that I see with this are people either messing up their matrix or forgetting that it goes plus, minus, plus. So just make sure you stick with those two basic rules and you should be good to go. If you have any questions with this, I know there is at least one practice problem, homework problem that involves this. If you have any problems, please let me know. I will be happy to help you out as quick as I can. But once again, get that homework done, bring in any questions that you have, and I will try to address them before we get done.